All right, so last time we did limits from graphs where you kind of just looked at a picture. I did unmute myself. It should be recording. I did unmute myself. All right, so last time we did limits from graphs where you just kind of looked at a picture and you were like, oh, both sides are headed towards 7 or, whatever it is. Today we're going to do limits analytically, which means that you don't have a picture to look at. You're going to have to just work it out by hand. So it is going to be more writing. And these kind of fall into several categories as to how you would approach the problem. So I'm going to kind of do them all separately before we mix them all together. So the first thing that you can do is just plug in the value. Like if it's limit as x approaches 3, just try to plug in 3, because if it works, that's your answer. I get people that will spend 15 minutes on a question and then finally realize that they could have just plugged in the number, and you will be upset. You'll be like, oh, why did I waste all my time doing this? So sometimes you can just plug in the values. Let's just try a few like this. It's really nice when this happens. So we're going to do limit as x goes to 5. We'll have x minus 1 over x squared plus 2. And so literally all you would do is plug in 5. That's it? Yeah. If that works, then great. So if you plug in 5, your numerator is going to be 4. Your denominator is going to be 27. So 4/27 is your answer. Again, if that's all that there is to it and you spend a whole lot of time trying to do something else, you're going to be upset. So just make sure you always try that first. I'm basically throwing this one on here just so that you can see that notation. Sometimes instead of x, they'll make it delta x for no other reason than to make it more confusing. Now, delta means change in. So, sometimes you'll see delta x instead of x. Same idea though, it's just your variable is delta x. So just try and plug in 0 for delta x. You would have e to the 0. What's that going to be? Anything to the 0 power. 1, good, plus 8, 9, square root of 9, 3. That's it. And then I threw this one in here basically just to review ln. So you're just going to try to plug in 1. And I brought this up a little bit earlier. ln of 1, 0. And that is one that you just need to know. ln of 1 would be 0 plus 5, 5. So again, I just threw that on there to review ln. Ln of 1 is 0. It has that asymptote, and then the graph goes like that. It goes through the points 1, 0. All right, so try and plug in the value. If it works, fantastic. So just always try that first. All right, if you try and plug in the number and you end up with a value over 0. So if you get 7 over 0 or 12 over 0, that means that there is an asymptote. So right off the bat, if there's an asymptote and your limit is not cited, it's going to be does not exist. So if it's not a cited limit, not a one-sided limit, if it's overall, then your answer is going to be does not exist. If there's an asymptote, you can only get an answer if it's from the left or from the right. So if it's overall, just automatically answers D any. All right, so if it is one-sided, you're going to test the denominator to see if it's positive infinity or negative infinity. If you have an asymptote, the graph is either going to go up or down. If you have positive values, it's going up. If you have negative values, it's going down. So you're just going to test and see if it goes up or goes down. And you will see what I mean when we do some examples. But at that point, you're just testing the sign. That's limit as x goes to 2 from the left of x plus 7 over x minus 2. So I know it's 2 from the left, but you still just want to plug in 2. Like I know it's 2 from the left, but still just plug in 2 and see what happens. So if we plug in 2, we're going to get 9 over 0. So at that point, your brain should be like, oh, there's an asymptote. So we're going to test 2 from the left and see what it comes out to. You only need to test the denominator. The numerator is already figured out. It's 9. 9 is a positive value. If you want to even put, I put like little pluses and minuses as like a note to self. 9 is a positive number. You don't need to test that. That's positive. We're going to test a value to the left of 2 down here and see if it comes out positive or negative. So give me a number to the left of 2. 1. If you plug in 1, 1 minus 2 comes out negative. So we have a positive over a negative, which would be a negative, and so this answer is negative infinity. If you had 2 negatives, they would cancel. It would be positive infinity. In fact, I'm sure I have one like that right here. Let's look at that. So I know it's limit as x goes to 7 from the left, but you still just want to plug in 7. We'll worry about testing what side once we see what it comes out to. Because again, I have these divided into sections so you know how this is going to turn out. But say you didn't know, you would just try and plug in the number. So 7 minus 10 would be negative 3. 7 minus 7, 0. That's where you go, oh, there's an asymptote. So we're going to test if it goes up or down. Negative 3 is a negative number. It just is. Negative 3 is negative. Give me a number to the left of 7. We want left of 7. 5 or even 6. Those are all fine. Okay, no, I'm glad that you brought that up though. You need to stay close to 7 because remember a limit means that you're zooming in on just that one point. And sometimes if you pick a number that's too far away, if you have a really weird graph, it might do something wacky over there. So you need to stay really close to the number you're talking about. So 5 is okay. I wouldn't go further away than that, but 5 or 6. If you plug 5 in here, 5 minus 7 is negative. So we have a negative over a negative, they cancel, and you would get positive infinity. And like half of you wrote that before I even got there. All right, let's try another one. So it's 4 from the right. You're still going to just plug in 4. So 3 times 4, 12, 4 minus 4, 0. So when you get a value over 0, that's when you go, oh, asymptote, we need to test this. 12 is positive. Like 12 is a positive number. It just is. That's the most common mistake I get with these ones. People try to mess with the numerator when you already have it figured out. It's 12. Now we're going to pick a number to the right of 4, at 5. 5 minus 4 is positive. So you have a positive over a positive, positive infinity. And we'll just try one more of these. So if you plug in 10, 2 times 10 is 20. 10 minus 10 is 0. That's when you go, oh, value over 0 means an asymptote. This one we don't have to test. We can just automatically write the answer. What is our answer going to be? Good. Why is it does not exist? Not one-sided. If there's an asymptote, you can't get an answer unless it's one-sided. So that one would just automatically be does not exist. All right, so this is if you have a number over 0, you have an asymptote. So if you end up with 0 over 0, That means it is what is called indeterminate. Which means that there's a hole in the graph. So indeterminate means you have a hole in the graph. So instead of an asymptote, there's a hole. And so we're going to deal with that the way we've been dealing with it back since, algebra 2. You get something to cancel out. Once that cancels out, the factors that cancel out are what makes the whole. Once you get those to cancel out, then you can plug in the value. So you're going to use algebra to get a factor to cancel out. And then plug in the value that you're approaching. So you have to algebraically mess with it until you get something to cancel out. Once you get something to cancel out, then if it's x approaching 2, just plug in 2, whatever the number is. These are the most annoying ones, just as a heads up, because algebra is what gets everybody. So you got to have good algebra skills. And they're the most work because you have to actually manipulate it until you can get something to cancel. Now, again, obviously, because I'm doing these bisections for you and showing you how to approach each one, this is going to turn out to be 0 over 0. But if you're taking a test or, the AP exam, you're not going to know until you plug the number in what it comes out to. So I'm still going to talk you through doing that. And you're like, Ms. Cole, we know what it's going to come out to. I know, I'm telling you, but if it was all mixed up, you wouldn't. So if you plug in -1 here, that would be 1 plus 5, negatives would cancel. So 1 plus 5 would be 6, minus 6 would be 0. And then down here, you would have 1 minus 1, which is 0. You cannot write equals 0 over 0. They don't give credit for that notation on the AP exam. And it is frustrating to me if you're like, man, that's weird. I agree with you. I'm on your side. Here's why not, though, because the explanation does make sense. 0 over 0 is technically not a number. So you can't say that it equals something. Does that make sense? So here's your way around it. Instead of an equal sign, you would put an arrow and say it's form 0 over 0. So that's your way around it. If you have to show that something goes to 0 over 0, but you're not allowed to write equals 0 over 0, it's frustrating. Anyway, that's what we're going to write. Arrow form 0 over 0. So what can we do to this to try to get something to cancel out? Factor. I'm not going to take off if you don't write the limit, but I'm going to strongly recommend that you write the limit. First of all, it should be there. Second of all, I'm going to tell you from experience, the people that don't write it forget to plug in the -1 at the end. They'll do the factoring beautifully and then stop and not actually get an answer. If you write that, you're probably not going to forget. So that's my suggestion to you, is just write it. So this numerator is going to split x and x, 6 and 1. We'll have a -6, +1. And then how's the denominator going to split? Yep, good. X plus 1, x minus 1. So we've gotten the indeterminate part to cancel out. The x plus 1s are gone. And again, I'll get people that'll stop there, because if you don't have this limit, then you just kind of forget what to do next. But once you get that to cancel, you're going to plug in -1, and then you should actually get an answer. So if you plug in -1, let's see, that would be -7 over -2. So 7/2. It seems like this is going over well. Are you all still okay? I made this one H instead of X. Those of you that took AB last year, do you remember limit as h goes to 0 and that whole definition? Okay, we're going to get to that soon, but I put this on here kind of as foreshadowing. What's that? Yeah, the definition of the derivative. Yep. We're going to get to that, not next class, but like soon. It's going to happen soon. All right, if you plug in 0 for h, this is gone, you would have 4x squared minus 4x squared. That would be nothing. And then this would obviously be 0. So it goes to form 0 over 0. So you're going to put arrow form 0 over 0, which means there's a hole. So again, these are the most annoying ones. It's all the algebra. It's a lot of writing. We're going to have to multiply all this out, get something to cancel. And then once we get something to cancel, we'll be good. So 4x plus h squared, that means 4x plus h times 4x plus h. I wrote that off to the side. You can if you want. If you're capable of doing it in your head, that's fine too. You don't have to write. It's not like a requirement. I'm just showing you what that would be. We're going to distribute this all to each other. So 4x times 4x. Good. 16x squared. The outsides will give you 4xh. The insides will give you 4xh. So together, 8xh. Again, this is all this fun algebra. And then h times h is h squared. So that is what we get when we multiply this out. Minus, and then if you have 4x in parentheses squared, that would be 16x squared. And then that's all over h. You're like, Miss Cole, we made it worse, not better. I realize it's longer, but something should cancel, and it does. These 16x squareds are gone. And then what can we do from there? Like, what's our next step? If you're capable of doing it in your head, that's fine. You can go and cancel it in this step. I'm going to factor the h out first so I can show everybody like where that comes from. Some people do skip that step, but they'll just do it in their head. That's okay. But I'm going to factor the h out. So if you factor out an h, you would be left with 8x plus h and then these cancel. Once you get something to cancel, you can just go ahead and plug this in. So if you plug in 0 for h, what's your answer? 8x. And then people are always like, Ms. Cole, there's a variable in the answer. That's okay. There was an x in the problem, so there's an x in the answer. We had an x and an h. It's okay. That is allowed to be there. So once again, if you try to plug in the value you're approaching, if you try to plug in 4, this will give you square root of 9, which is 3. 3 minus 3 is 0. Down here, 4 minus 4 is 0. So it is indeterminate. There is a hole. You can't factor. It's a square root. Do you guys remember multiplying by a conjugate? Or do you remember what a conjugate is? Like if you had x plus 5, the conjugate would be x minus 5. The idea is that you want to get stuff to cancel out. So we're going to multiply by this, except instead of a minus 3, we're going to have a plus 3. So we're going to multiply by that in the numerator and the denominator. My suggestion is write it twice. I wouldn't skip that. Because if you don't write it, you're not going to be able to see what actually happens. And the goal is to get something to cancel. So the conjugate is the same stuff, but the opposite operation. Instead of a minus 3, we had a plus 3. All right, so I'm going to keep the limit. And when we multiply this out, the roots are going to cancel. If you have square root of x plus 5 times square root of x plus 5, that's just going to be x plus 5. Do you remember that like square root of 2 times square root of 2 is just 2? It's that. And now when you do the outsides and the insides, you're going to have plus 3 square root of x plus 5 and minus 3 square root of x plus 5. Do you get why we did that? Like the outsides and the insides are going to go away. And then negative 3 times positive 3 will be negative 9. Now, that usually goes well. People are just like, okay, like we have to do that, fine, we'll do it. Here's where I see the most common mistakes is people will mess with the denominator. Listen to me. What should you do to the denominator? Nothing, leave it. Like I would put parentheses around that x minus 4, but literally just copy it over. Like don't do anything to that. If you start trying to multiply that out, you will end up with a whole lot of mess. Like just leave it. We worked hard. Let's stop, take a step back. What do you notice? Not yet. We have one more thing we can do before we plug in 4. Yeah, why does it cancel? Because it does cancel. Yeah, x plus 5 minus 9 would be x minus 4. So those are gone. And now we can just plug in 4. Oh, but what's the numerator? It's all gone. So 1. So our numerator is 1. And our denominator, if we plug in 4, 4 plus 5 is 9. Square root of 9 is 3. 3 plus 3 is 6. So 1, 6. I'm going to give you guys one like that to try. I want you to try it, and then I'll go over it. And you guys can work together. I'm going to pause the recording here. All right, so it went to form 0 over 0. Our conjugate was square root of x plus 5. And when you multiply these together, square root of x times square root of x gives you x. The outside and inside cancel. Negative 5 times 5 gives you negative 25. Denominator, do nothing, right? And then these are going to cancel. You just have to put a negative out front. So you cancel them out, stick a negative out front. Because if you were to distribute a negative through 1, like, do you get what I'm saying? Okay, so our numerator is negative 1. And then in the denominator, we're going to plug in 25. So square root of 25 would be 5. 5 plus 5, 10. Went okay? All right. The last type of these ones to do analytically, if it doesn't come out to indeterminate and you can't just plug in the value and there's not an asymptote, if like all else fails, draw a graph. Look at it from a graphing standpoint. Like if everything else fails, this is like your last ditch effort. Like nothing else works, then look at it visually. Just give yourself a visual aid. Which no one ever wants to do this because no one ever wants to like actually draw a graph, but it helps to be able to see it. What does that mean? The graph that has like the double brackets? That's greatest integer. What does that look like? Yes, the step graph. We're doing those in pre-calc right now. Like we're doing all the parent functions. So it's a step graph. It's been moved up 1. So what I would do is just off to the side here. And I'm not going to draw like a whole ton of these steps, but I need to at least go out to like 3 because that's the value that we're approaching. So we're going to start up 1 and then draw in our staircase. How long did that take? Like, Not long. Like people give a hard time about like having to draw a graph. I'm not looking for like the Mona Lisa, you know what I mean? Like just a quick like sketch so that we can look at it. We want to approach 3 from the left. So here's 3. If we want to approach from the left, that's from this side, like we're going this direction. Now I realize there's an open circle there, but it doesn't matter. It's just where are you headed? The step that we are on is at 3. So that would be 3. But let's do the exact same problem, but from the right. Limit as x goes to 3 from the right of the exact same graph. So you're not going to have to draw another graph. We've already got it right there. So I recopied the problem, but put a little plus sign in there. So if you're approaching 3 from the right, that's right here, drawing a little arrow there. And so there, you're on the step that's at 4. Now, a lot of people just kind of like almost memorize that or be like, oh, well, if it's from the left, it'll be this. If it's from the right, it'll be that. And you can do that. I'm not ever going to force you to draw a graph. I'm just saying it helps visually. I like to draw a graph. And I like to review the LN graph as much as possible, because if you just know what this one looks like, it helps you with so many things. The LN graph has an asymptote, vertical asymptote, and then it's like a sideways swoop. It's the inverse of exponential. Now this one's been shifted left 2. So if you draw that graph, instead of having the vertical asymptote at 0, it's going to be left 2. So it's going to look like this. And again, if you just have a basic understanding of your parent graphs and then you can shift them around, you can get that graph really quick. Or if you don't want to draw it, like if your brain will do that, like you can just look at it inside your imagination. That's cool. As a teacher, I have to draw it though, because I'm trying to show it to all of you and I can't do that just inside my brain. We're going to -2 from the right. Now there's an asymptote at -2. If we approach from the right, where are we headed? Yeah, -infinity. We would have to approach from the right, wouldn't we? Because there's nothing on the left side. All right, one last kind of graph we're going to look at here. Thank you for bearing with me. We're still going to end early. I like these graphs. Actually, let me just go ahead and write the last problem as well. We can look at them together. This looks really complicated, this absolute value of x over x. The graph is actually really basic. So actually watch me draw it first. And then if you want to draw it too, you can, because if you like look away, you're going to miss it. Absolute value of x over x. There's going to be a jump discontinuity at 0. And you're going to have values at +1 for everything after that and -1 for everything before that. Think about it this way. Say you plug in 1, you're going to get 1 over 1, which is 1. If you plug in 2, you're going to get 2 over 2, which is 1. 3 over 3, which is 1. 4 over 4, which is 1. That's why this is consistently at 1. And then you're going to get the same thing going the other way, except it'll be -1 for all the negative numbers. These are both open circles. Does not exist at 0. F of 0 does not exist. All right, we want to approach 0 from the right. It's either +1 or -1. What do you guys think? Yeah, because you're going from the right, you're on this part of the graph, so it would be a +1. If we approached from the left, -1. If we approached overall, does not exist. Okay, now this graph is the exact same thing shifted right 4. This is a transformation to the right 4. So it would look like this. Sorry, I tried to label the axis with 4, but then my graph went over top of it. You guys know that's 4. You can count. So from the left, this is going to be -1. And again, a lot of people will just memorize, oh, if I go from the left, it'll be -1, and from the right, it'll be +1, and then they won't even bother drawing a graph. But again, I like to draw the graphs visually. I'm also using this by way of foreshadowing, because we're going to get to this later this unit. This is a derivative graph of one of the parent functions. And so when we get to that, you're going to be like, oh, I remember that because she brought that graph up before.